Hey guys, here we are again at Unit 8, Section 3. This is page 3. So right now we're working backwards because now we have the graph, we have the whole, we can pinpoint where the vertical asymptote is, we know where the horizontal asymptote is. Even if I didn't have those graphed, you can clearly see that the graph is approaching that line right there where y equals 3. And then right there for the vertical asymptote, you can tell that the graph is approaching x equals -1 right there. So with those things, and I know the whole is right there where x equals 2. So I'm going to start by writing my rational function right there with the whole. And if you want to write it, you can, but you know, we've done so much of this that it's kind of second nature now. So when you have the same factor for numerator and the denominator, you know that's the whole. The other factor right here, that's the x-intercept. That's where this came from. So since the x-intercept is right there at -3, 0, the factor that corresponds to that, that's x plus 3. So that's x-intercept right there. I know this one is the vertical asymptote, and I can pull that information from the graph right there, y equals -1. Now, when you ask, where did that 3 come from, right? When I compare the degree of the numerator with the denominator, they both have the same degree. X times x is x squared, so the degree is 2 for both numerator and denominator. When the degrees are the same, I have to divide the leading coefficient. So if my horizontal asymptote is right there at 3, well, when I divide them, I need that number to be 3 over 1. Okay? The horizontal asymptote right there, y equals 3. Vertical asymptote right there from the graph, x equals -1. Y-intercept, x-intercept. Whole I didn't even have to calculate because I can see where that is. And the domain and range right there. So the domain is all the numbers from starting right there at -infinity, go, all the way, whoop, there, gap on the graph. There's a break on the graph where the vertical asymptote is right there at -1. So that's your -1 right there. And then it keeps going until there's another break on the graph right there where the whole is. So from -1 to +2. And then it keeps going toward positive infinity. And same idea goes for the range. It starts right there at -infinity, go until there's a break on the graph right there at the horizontal asymptote where y equals 3. So there's the break right there at 3. And then the next break is right there where the whole is at 5. And then it keeps going toward positive infinity. The next one, we're going to follow the same idea. I'm going to try to find the main attributes for the rational function. So I have 2 vertical asymptotes at this time. And I don't have any holes right here. So vertical asymptote right there at x equals -2. So that makes that the factor x plus 2 right there. The other vertical asymptote right there, x equals +1. That makes that factor x minus 1. So these are my 2 vertical asymptotes right there, here and here. And then I have the x-intercept right there at 4. And I also have the other x-intercept right there at 0. You know, x plus 0, that's just funny. It's just silly. We're not going to write that. So just x. And next, we're going to compare the degrees of the numerator with the denominator. And they both have degree 2, because x times x is x squared. Same thing for there. For the denominator, when the degrees are the same, you have to divide the leading coefficient. 1 divided by 1 is 1. That's why the horizontal asymptote right there is y equals 1. That's the leading coefficient when you divide right there. So that's the horizontal asymptote. That's the vertical asymptotes, plural, because I have one right there at -2 and another one right there at 1. I have the x-intercept right there at 4, and there's another one right there at 0. Y-intercept is also at 0. No holes, and then the domain is everything from here over to the first vertical asymptote, and then over to the second vertical asymptote right there at 1, and then it approaches positive infinity. Now the range is everything. There's no gaps, there's no breaks in the graph, and I know you want to do the break on the graph right here for the horizontal asymptote, but notice how this one right there in the middle, it keeps going. Okay, there's not a break there. So theoretically, your range is everything from negative infinity up to positive infinity. Moving on with page 4. So now I don't have the graph, but I have all the attributes right here that I would be able to pull from the graph. So the vertical asymptote is at x equals -2. Well, that's my first factor right there. That's the vertical asymptote right there. X-intercept goes on top right there, x plus 3. Since the x-intercept is at -3, 0, that makes that a factor as x plus 3. Y-intercept is 0, 3. Meh. I will deal with that in a minute. And then I have a hole right there at x minus 4. And I know that would have to match the factors for both numerator and the denominator. And then horizontal asymptote, that was given to you, easy money, as the y equals 2. Since you have the same degree for numerator and denominator, you would have to divide the leading coefficients. Since I know my horizontal asymptote has to be at y equals 2, well, 2 divided by 1 is 2. So this, if you want to draw the arrow right there, that's pretty easy to understand. So this is your factored form. Moving from factored form to standard form, I did FOIL there, and I got this for your numerator, x times x, and then you combine -4x and +3x, that's -x, minus 12, and then you have the 2 right there as the leading coefficient. That's how I went from here to here. And then I just did FOIL right there on your denominator to get that. Last one on page 4. Same idea. So I have the vertical asymptote, only one, at x equals 4. So that makes that the factor. Vertical asymptote right there. That's my denominator factor. Now I have two x-intercepts at 2 and at -4. So that makes x minus 2 and x plus 4 for your x-intercept, plural x-intercepts. The slant or oblique asymptote, she gave us the function. I will deal with that in a minute. The hole right there, since the hole is at -3, then I know both factors will be for the numerator and the denominator as x plus 3. And then the y-intercept at 0, 2. Okay. So what am I going to do with this thing right there? I'll get to it. So now here I have the degree of the numerator is greater because here I have x times x times x is x to the third power compared to x times x, it's x squared. So the degree of the numerator is greater. Okay, so that means I do not have a horizontal asymptote. That's where the slant asymptote comes in. And you're like, okay, how do I get that? Well, I get that by dividing, not including the whole, by dividing the numerator by the denominator. But this one has to be in standard form, so I can use the coefficients there. So x equals 4 from this factor right here, and I did FOIL there to change this from factored form to standard form. That's where I got 1, 2, -8. FOIL. So synthetic division right here real quick. Drop it down, multiply, goes there, add, multiply, goes there, add. That's a remainder. So your linear equation for the asymptote will be 1x plus 6. So this checks with that. Perfect. So now I already have this. I have to multiply by the whole because we also need to write the answer in standard form. So from standard form here, I multiply by the whole. This is my math. There's a whoopsie right there, so there should be a minus. When you combine, you get the -2x right there. And then same idea here, you FOIL to get that. Easy money.